Hey there, welcome to the online edition of CMIS468. Chapter 10 is what we're getting into. I'll talk about our exciting live session this coming Wednesday, as well as some other topics around the exam and explain how Chapter 10 works. But first, a hat and a t-shirt. So today's uh, session is being sponsored by, not really, brought to you by Jeff Beck. So Jeff Beck is a guitarist from the 60s, 70s, 80s, 90s, 2000s. He's still playing. He's been around for a long time. He started off his career in the Yardbirds and then played with the Faces, where he played with Rod Stewart, that you may have heard of. They've had an on and off again partnership through the years, but I saw him as a solo artist in 2018. With some other awesome groups, including Paul Rogers and Ann Wilson from Heart, and great show. In fact, there was a SIUE GA that worked at the T-shirt booth at the amphitheater there, and he hooked me up with oh, come back later and we'll have your size T-shirt. So that was pretty cool. It's good to know people. So here's just a little taste of Rod Stewart and Jeff Beck. Well, I'm not going to show you the whole video, A, because I don't want to get busted by YouTube again and have my video pulled for copyright infringement. But B, I will burst into tears if I hear that whole song once Rod Stewart starts singing. So we'll hear the rest of that at the end of this session. How's that sound? Yeah, hat, t-shirt, homework 7 was due a while back. If you haven't done it yet, just go ahead and do it, please. We're running out of time. Homework 8 is due on the 15th. Again, if you need a few more days, that's okay. It's an important assignment, a business writing assignment. I want you to do well with that one. So if you need a little extra time, just take it, okay? And like I said, Wednesday is going to be our live review session. I have no idea how this is going to work out. Maybe it does, maybe it's a train wreck, but it'll be a train wreck together, right? So what you're going to do is, please, a few minutes before 3 o'clock on Wednesday, click that Zoom link, and let me just go ahead and pull up the invite. Here's what I posted on Blackboard. All you need to do is click this link, this siuezoom.us, and then that's the meeting ID. Note that these two numbers are the same, so you don't have to key this in anywhere. It's just click this link. If you want, just join with your computer audio. If your computer audio doesn't work very well, you can phone in to hear and to speak. If you want to turn on your video camera, feel free. If you don't, no pressure. We're just going to try this out. I'm going to answer your questions, do a little review. We'll see if we can get the technology to work for us. And part of this is just to, as Katie Robertson says, remind you that there's a human being behind Blackboard. Isn't that nice? So live class session on this Wednesday. The study guide is already on Blackboard. Take a look at that. That's what we'll be going over together. Exam number 3 I'll post on April 20th, but then just like on exam 2, I'm going to give you a range, a couple of days to take the exam when it's convenient for you. And deliverable 4 is going to be your practice exam, your practice certification exam for Network Pro on Test Out. So that's a biggie. I do need you to do that by the 22nd. If for some reason you just can't make that date, please let me know immediately or as soon as you can. And videos, what I'm going to do is I'm going to give you part 1 of chapter 10. Part 2 I've already got on YouTube, so that's going to be a rerun, but just a rerun from last year. It's not like it's that old, unlike some of the other videos I've shown you. Yeah, so let's get into it. We did the Zoom invite. If we're in person, I'd kind of grill you on some of these questions, but we'll do this together on Wednesday, things that you should be a little more comfortable with at this point. Chapter 10 might be the most challenging chapter in the Panko textbook, simply because wide area networking is something that college students typically have no experience with, and it is highly unlikely that you're going to get a job straight out of college working on a WAN support team. It's much more common that if you get a job as a network administrator, you'll be supporting the LAN, the local area network, not the WAN. The WAN is so important, they're not going to trust a new person with the keys to the kingdom like that, and we'll get into why. What are we doing in chapter 10? This is the last chapter. It's the last chapter, so I need to get philosophical with you. And by the end of this chapter, I want to answer the philosophical question of what is inside the cloud? What is the cloud? What is the cloud all about? I have an answer for you at the end of the wrap-up video. You may fight me on this, but just let it wash over you. Okay, the answer is profound. So let's get started. LANs, MANs, and WANs. LANs are local area networks. That's what we've been talking about 90% of the time in this class. The LAN is defined as the network that's under the local network administrator's control. It's on the customer premises. And premises is an important term in telecommunications. If you're talking to a telco, they might ask you if this is, are you having trouble with your prem equipment? Prem equipment, as in it's on premises, it's your stuff, as opposed to WAN gear, which you have no control over, right? The telephone company, the ISP, Charter Communications, cable company, whatever, has control over all the WAN gear. The WAN is what connects different LANs together across the country and across the world. A MAN, metropolitan area network, is a hybrid. It's halfway between the two. If you want to think of a MAN as an extended LAN, like a LAN that has some satellite locations, or as a small WAN, different companies kind of view this differently. For me, at SIUE, our metropolitan area network includes things like the Dental School of Medicine in Alton, the East St. Louis Center. Those aren't on our campus premises, per se, the main campus, but they are part of our extended local area network. So that's why I'd consider that an example of our metropolitan area network. It stretches across a metropolitan area network. Okay, who's the carrier? The carrier is the one providing the wide area networking services. So on the LAN, you, the network administrator, are 100% in control of the implementation. You can choose whatever technology you want, although you're going to be picking Ethernet for your layer 2 protocol and routers and switches, TCP/IP. I say you have a lot of choice, but really these are all pretty industry standard. Who manages I can't even speak. Manages it. You do. On the WAN side, the carrier takes care of. The carrier doesn't say implementation. The carrier uses a different verb called provisioning. Provisioning is just a word meaning setup, initial configuration, and the carrier does that. You can't pick what your carrier provides. Maybe they provide, let's pick something like Metro Area Ethernet or MPLS or Google Fiber. Maybe that's available in your city. Maybe it's not. Depends on where you live. So you don't have the ability to pick and choose. You're at the mercy of your WAN carrier, and the carrier obviously manages their own network. A important principle of LAN versus WAN is that your LAN speeds are always better than your LAN speeds are better than your WAN speeds. Your WAN is always going to be slower than LAN. This is counterintuitive to non-IT people, muggles, people that are not network administrators. They kind of assume that, oh, my WAN bandwidth should be, the pipes get bigger and bigger and bigger. Well, yes and no. The problem is it's this cost per bit transmitted that we need to understand. The cost per bit transmitted on your local area network is very, very low. The cost per bit transmitted across a wide area network is very, very high. Why? Distance. As distance increases, cost increases. So typically you're not going to, even though you've got a gigabit per second LAN connection, you are very rarely going to have a gigabit per second WAN connection. It's just too expensive to have that kind of throughput all the way through the WAN link. So typically your WAN link is going to be anywhere from 1 to maybe 100 megabits per second, just typical speed. As I said, a WAN is that which connects two or more LANs together. That's all a WAN is good for. You're going to have, so this is our little silly icon for a router here. I don't like that icon. I like the XX on a circle Cisco icon for a router. But here's our router. It's part of our prem equipment because I control this router, but then the access line connects me to the WAN core. The WAN core might represent a private WAN, like with a telephone company. It might represent a public WAN, like the internet. And I'll show you the difference in more detail than an access line on the other side connecting to your second site. So that's a high level of how a WAN works, but obviously there's a lot more to it than that. If you're a business manager, this is how you understand WAN works. Some magic happens to connect the two, but we need to dive in a little deeper. I need you to be very comfortable on this distinction between a public WAN and a private WAN. They both serve the same function of connecting LANs together, but the internet, which is probably the more common way at this point, ubiquitous is just a fancy college word meaning it's everywhere, and pretty cheap. Why do we know it's cheap? Well, because you can afford it. You're probably watching this over the internet right now, and if a poor college student can afford this, we know it's cheap. But it does lack QoS. Remember, that stands for quality of service, and which is typically something a business needs. Maybe your internet goes out. Maybe you've had trouble with Hulu, with Netflix, with Amazon Video while we've been on this extended quarantine, and it goes out. You're slightly inconvenienced for a few minutes if it gets laggy or if it just kind of bleh, like my Hulu keeps rebooting itself for some reason. But if you're a business, that's no good. You need quality of service. Well, you pay more for that. One way to get excellent quality of service is to just abandon the internet and pay for a private WAN link, a leased line from a telephone company, which does give us quality of service, but is much more expensive. A hybrid WAN then just is a kind of weird term that describes a company that might use a combination of both. They might use private WAN for some locations and a public WAN for other locations. This one is becoming more popular just because IPsec, the most popular test question, the most popular VPN encryption protocol around, IPsec, reduces security concerns. It does not eliminate security concerns. So a virtual private network is virtually private, meaning it is not private. It's pretend private. It's pretend private because it's encrypting all the traffic, but it's really on a shared public circuit. All right, here is where this is typically a very big part in the semester where I use up the entire whiteboard in our classroom to show you the difference between a public and a private network. And I can't do that easily, and I think trying to draw it on a whiteboard electronically here would be it'd be tricky. So what I've done is I have created a pretty detailed PowerPoint example of what I draw on the whiteboard. This took me a lot of time, but I think it was worth the prep work to run you through this. Hopefully this helps you out. Okay, are you ready? Here we go. So in light blue, this is our first example is a private WAN. This is a traditional, typical connection to another location through the telephone company. So say this is our corporate headquarters down here. I've got another manufacturing location in Texas. I need them to be able to communicate and share information back and forth. Duh. Let's say one of the business requirements is that this needs to be secure, stable, high quality of service. So I need to purchase a dedicated circuit. It's going to be stable. There's one carrier that I'm working with. It is expensive, and stationary just means it's not very flexible in terms of moving it around. This is for connecting to buildings that aren't going anywhere. This isn't something you would do to connect to a mobile user, for example. That's what I mean by stationary. And it's very slow to provision this. I think I mentioned previously what I mean by slow. In the US, 30 days to to provision this. Internationally, 90 days to provision this. Step one, I know I need a router. If I want to connect my LAN to anybody else's LAN, I know I need a router. So I need a router on both sides. This will be on the premises of each location. So this router is prem equipment. But how do we connect these two routers together? Well, that's what the carrier does. So let's add the carrier. Let's use as an example AT&T. I'm going to pay AT&T for a leased line from my corporate headquarters to Texas, which means I need an access line here. I need an access line on this side. The WAN core is AT&T's network, so I'm just using a cloud to represent AT&T's network. There is a router on the other side here, so routers talk to routers. The place where the telephone company's routers are located is at a concrete bunkered building called a CO, the central office. The CO serves as your point of presence. Your point of presence is just a generic term for how you get access to a wide area network. So your point of presence, that's just the next stop, how you get onto their network. So for example, I'll give you an example later. Let's keep it easy for now. This access line, just to introduce you some other telco terminology, sometimes this is called the local loop and sometimes it's called the last mile. All means the same thing. But let's stick with access line for this side. Trunk lines are inside the carrier's network. So we've successfully connected these two sites, but oh, what's this? We've got a new location in Germany opened up a manufacturing facility, and they need access to both locations. But let's say for now, just back to the corporate headquarters. And AT&T is not in Germany. Instead, their telephone company is called Deutsche Telekom. So DE is the country code for Germany, Deutschland. Deutsche Telekom is going to be our WAN carrier in Germany. So AT&T's network is going to connect to Deutsche Telekom's network. It's something called a network access point, NAP. I don't think I'll have that on the exam. It's just a little too obscure. But in Germany, they're going to have a point of presence that connects them to Deutsche Telekom, and then Deutsche Telekom and AT&T connect on the back end. And you as the customer don't have to worry about this connection. You don't support it. It's not your responsibility. That's what you're paying them to do. Notice that you still have one carrier, though, that's responsible for all this. AT&T is responsible for setting up all this, even though it's not going across their network per se. I do want to mention another concept, which is called the legal demarc. The legal demarc, which is the point of legal demarcation between your stuff and my stuff, between prem equipment and carrier equipment. I mentioned that the NAP is the legal demarc between these two carriers. The legal demarc between you and AT&T here is not your router. It might be, depending on how they set it up, but more likely your router plugs into a little box in the wall, maybe in the basement of your building, wherever all the phone lines come into your building, and I'll show you a picture of that. There's a little box called a CSU DSU. Don't worry about what it stands for. It's just a little box with two blinking green lights. One's inside and one's outside, and that's just the box where it transitions legal ownership from your network to the carrier's network. And if one side is yellow, it tells you exactly which way to point the finger about whose problem it is. So if it's yellow or red on your side, the carrier is going to say, you know what, it's your router or something on your network you need to fix. But if it's yellow on AT&T side, I know that I can use my telco support device, because I don't have access to their routers. This is all I can do is call them up and say, hey, you need to fix this. Can I show you a picture of my CSU DSU? Ooh, look at that. Oh, it's not working. That's how you troubleshoot this. Now, this is a simple example of a private WAN, but it's, I think, a typical one. So a private WAN, again, light blue, private WAN, we've connected 3 different sites securely because it's a dedicated circuit. I'm paying for these dedicated circuits. I'm not sharing them with any other companies. It's stable. AT&T is giving me a killer service level agreement where they guarantee quality of service. There's one carrier, even though Deutsche Telekom is in the mix, I call AT&T for all my problems. That's one of the things that I get when I pay this much money, by this much money. I mean, thousands of dollars a month. It's stationary, so I'm connecting stationary locations together. It is slow. Ready for the other side? Let's wipe the whiteboard, as it were. Boom, because now I want to show you a public WAN example of the same thing. So my same corporate headquarters, I've just got it down here in the lower left-hand corner this time. What I want to do is use a public WAN to connect my Atlanta sales office, a telecommuter at home, like a lot of us are doing right now in quarantine. We're telecommuting from home. And just to make it international again, because most networks have a very strong international component, a Toronto sales office. And you know what? I need to make sure. Okay, Toronto sales office in Canada up here. The difference here with a public WAN, it is inherently insecure. We're going to use the internet, so you can't tell me the internet is secure. It's just not, because we're running over shared circuits. Every company is using the internet, so it's lots of different traffic going over the same circuits. It is unstable because it's the internet, and there will be multiple carriers, as we'll see, and we have to worry about all of them. That's what makes this a little more complex. It is cheap for the reasons I said before. If a college student can afford this, companies can obviously afford this. It's mobile in terms of meeting the needs of telecommuters and people sitting at McDonald's and Panera Bread and Starbucks. They can crank up their Wi-Fi and VPN back into their corporate office. And it's fast. I mean, it's faster than 30 days. I don't know what Charter's typical turnaround time is, but I think it's a matter of days, not weeks, that they can get this set up for you. So there's a lot of fundamental differences between these two approaches to wide area networking. Well, how does this work? Well, we know that we still need a router on our premises, but that router is going to connect to a cable modem, assuming that we're using cable modem technology. There are some other options, but this is certainly popular around here because Charter is huge, and they do have a business class service, not a residential service, a business class service. In fact, I think they prefer to brand that as Spectrum, so we'll say Spectrum. The point of presence is the again the on-ramp to the information superhighway. It's the next hop after your cable modem talks to a bank of basically cable modems or switches in Charter's point of presence, which is known as a head end. So a cable company doesn't have a central office, they have a head end. It's just good terminology to know. I visited Charter's head end in North Carolina. It's very impressive. It's a bunker data center set up with barbed wires and spotlights and dogs, and they take physical security very, very seriously. So you are paying for an access line to your point of presence. So in our case, in Edwardsville, Illinois, the point of presence is not in Illinois. Our point of presence is actually the data center in St. Louis. So if you're troubleshooting a connection with Charter and you call them up, ask them, where's my point of presence? And if they say St. Louis, you say, okay, are you having any trouble with St. Louis? Because if you call up and say, I'm having trouble in Illinois, they're going to say, oh, we don't have any outages in Illinois. That's happened to me twice now. So it's important to know where physically your point of presence is. Trunk lines are on the back end. Access lines are what connect prem equipment to the WAN carrier. The Atlanta sales office, similar, Charter's not in Atlanta. Charter's not in Atlanta. I just know this. Their cable company is called Comcast, another biggie. So the Atlanta sales office will need a cable modem to connect to their point of presence in Atlanta and connect to Comcast cloud here. So Charter's cloud down here, Comcast cloud down here. Our telecommuter at home may be out in the middle of Illinois, central Illinois somewhere. You don't have a cable modem. The best you can do is a DSL modem from Sprint, your phone company, CenturyLink, any number of phone companies. Again, whatever point of presence, this is just the generic term that Sprint has, you're going to connect from home. Similar situation in Canada. Our Toronto sales office in Canada will say that they don't have a cable modem, and in fact, you're going to use the phone company in Canada is what you're going to do. So a DSL modem here, we'll talk about what that is later, is going to connect you to Rogers Communication, which is the biggest telecom provider in Canada. So it's going to connect you to their cloud. So we've got 4 different clouds here. How do we connect these clouds together? Well, that's what the internet does. So in this case, the WAN core is not, in the first example, was AT&T's network. In this example, is just the internet. It is the interconnection of different clouds together. So however Comcast connects to the internet, however Sprint, Rogers, and Charter connect to the internet, there are multiple clouds here, and the signal gets through. This is what I mean by multiple carriers that we're going through, which adds to the complexity of using a public WAN. But why do we do it? Well, because it's cheap. Now, because we're using the internet, we better use a firewall, because these are all shared circuits, public internet, everybody has access to this, so we've got to have a firewall at each location. But security doesn't stop there. In addition to a firewall, we better be using a VPN to make this virtually private, because it's not private, it's public. How do we do that? Well, we're going to set up our firewall here is probably going to serve as a VPN gateway of some sort. Depending on the manufacturer, it's going to be called a gateway or a server or a concentrator, depending on what manufacturer you go with. But doing it this way, a hardware VPN is always going to be faster than a software-based firewall. So our telecommuter here has to load some software for a mobile VPN. But for a site-to-site VPN, I can connect this firewall to this firewall with a VPN, and its throughput is a lot better. It doesn't go on and off and on and off. It just stays on, unlike a mobile VPN that the end user has to bring up whenever they want to connect back to the corporate headquarters. So Atlanta and Toronto, I've got a site-to-site VPN. Here's a mobile VPN. They all talk to my main VPN gateway here at the corporate facility. And just to make it a little more messy, let's draw with a little orange line to represent the VPN or encrypted traffic that's going through the internet, just so we see how this works. So this is our final picture of a very common example of a public WAN. We're using shared circuits. It is not the most stable thing in the world. It's pretty good, but we can't call it stable, not compared to a private internet. Multiple carriers, I've given you examples of multiple carriers. It is cheap in the couple of hundred or less a month, as opposed to a couple of $1,000s a month. It is mobile in the sense that we can get our mobile users connected this way, and fast provisioning, we said. Now, this is the big moment. We're going to put it together into a even more typical hybrid network. Okay, most companies use both. Ready? This is a big moment. Let's make sure this works. Boom. Oh, look at that. What did Tim do? Yeah, I just joined the two together. So we have our same corporate location, but we've got all of our private connections over here on our network diagram, all of our public WAN connections over here, and I just moved them together. Now on the whiteboard in the classroom, this is much more impressive, and I use different color markers for everything. It's a thing of beauty. Actually, it's the ugliest thing in the world. But it is impactful, and this is the point in class where you'd be standing up and you'd be applauding me for the brilliance of this network diagram. I can hear your applause now. Thank you. Thank you very much. Whew. Oh, that wore me out. Okay, here, now back to just some definitions, some test-worthy definitions. Obviously, the internet is a WAN. It's the biggest public WAN there is. Talked about price, security, quality of service. We've covered all this in detail. IPsec for VPN encryption. SSL TLS is just for web traffic, and it's less secure. It is encryption. They're both encryption, but IPsec, what does that encrypt? All traffic. SSL TLS, what does that encrypt? Just web traffic. We talked about the trunk lines that connect different locations on the public switch telephone network, so that the telephone company's network. Access lines can be called the local loop. This is typical phone company lingo. Ignore this term end office. Nobody calls it an end office. It's either head end for the cable company or a central office for a phone company. There's no such thing as an end office. And this access line might be typical phone wiring, and might be fiber. Remember that fiber does not make it faster. Fiber means I can bring you a fast connection further. Fiber helps with distance, not speed. I forbid you to ever say that fiber's faster. It's just not, because a gigabit per second fiber connection is exactly as fast as a gigabit per second copper connection, sorry, twisted pair connection. The difference is the twisted pair, Cat5, Cat6 cable, is that short, and fiber connection can be kilometers in length. That's the difference, distance. When I mentioned before the legal demarc, where your cables come into your building, this is what I mean. It's usually just a hole in the ground where the cables come up out of the concrete floor in the basement. It's nothing sexy. I mean, this is physical stuff that's got to get into your building somehow. And then it's going to terminate. Usually it kind of runs with alongside your power, so your phone, network, and power all are usually in the same utility closet. Here's an example of like phone and data being patched in. Sometimes this is in a nice rack. Sometimes it's just a piece of plywood nailed to a wall. So for a small company, it doesn't have to be anything complicated. Larger companies are going to look a little nicer. So a business might have multiple connections coming into their building, whereas at home or at your apartment complex, it's a little simpler. Now I want to show you something. This is called a NID, a network interface device, and you have one. You have one outside your house. You have one outside your apartment complex. If you want to walk around, even though we're in quarantine, you can probably go around and find the NID on your apartment complex. It's just going to be a little gray box. You'll see that there's a little place where you can put a padlock on here to lock it up. Most people don't. They should, because if you open this up, you'll notice that there's a little phone jack on the inside, and so this is the legal demarc between you and the phone company. So there's two sides, an inside and an outside, and this is where the telephone company tells whose problem it is. But if you wanted to, you could take a handset and just plug in, click, right, so you can't see where I'm pointing, right here into this RJ11 jack, and you'll get dial tone, and you can make outside calls for testing purposes. What's fun is back in the day, back in the olden days when we used to have to pay for every call we made, you could take a handset to a neighbor's house and plug in and make a call, like a long distance call, and it would get charged to their phone. That's obviously illegal. Don't do that. I'm just saying physically this is possible. The other nice story about the NID is this, if you don't mind me sharing this. I didn't know who created this until I read his obituary. And the network engineer who invented the NID in the early 80s his name was Joe Hicks. And Joe was my first CEO. He was the CEO of C-Core Corporation, which was later acquired by Corning. But C-Core was a joint venture between Siemens and Corning. Siemens made all the manufacturing equipment, Corning made all the glass, and so C-Core made fiber optic cable, and we also sold these NIDs, but this was Joe Hicks' claim to fame. I just knew him as an executive, and super nice guy. But he invented this, so that's nice. Okay, I got you through the first half of chapter 10. The rest of it is going to pick up on a rerun in these two, these two YouTube links, which I'll post on Blackboard, and that'll take you through the rest of the chapter. Let's go out with some more music, and even though this is chapter 10, we've still got more to talk about this semester, so this is not our last time talking to each other. So until then, as the song says, have pity on those whose chances are slimmer.